So now we're coming up to the next session, which is going to be on empowering Europe's green transition and the crucial role of critical raw materials. It will be headed by Professor Franco Bonollo. He's the president of the School of Engineering at the University of Padova in Italy. His main research topics, so just a brief introduction, are foundry and solidification of light alloys, aluminium matrix composites, innovative welding processes, and simulation of metallurgical processes. And he's also recently developed an online training module on aluminium technology. So he's at the forefront of everything that we're doing in SALEMA, so welcome.
Thank you, Anna, for the introduction. Good afternoon to everyone. Okay, this section is devoted to critical raw materials applied to some specific issues. And obviously, we wanted to discuss about empowering Europe's green transition and the crucial role of critical raw materials. So, according to the traditional way of introducing metallic materials, we have on one side base metals, iron, copper, aluminium, magnesium, zinc, and really very important for the innovation and technology development, we have technology metals, including lithium to beryllium to scandium to rare earths and so on. This is our general overview. And more specifically, there are some technological innovation related to saving of energy or to automotive, which are strongly related to the use or combine the use of base metals and technology metals. For instance, if we are discussing about LED lighting, we have on one side copper, but also lanthanum, europium, cerium, and so on. If we are discussing more conventionally about electric car, we have iron, aluminum, as we discussed this morning, copper, but lithium, neodymium, and so on. So the point is that the technology metals, base metals are not the only categories, but we have to discuss about the relevance of critical raw materials. Every material we are using here in Europe has to be considered from the point of view of its economic importance. So which are the applications strategic for this material, which is the value of the related sector in Europe. So this is an indicator of economic importance. And on the other side, we have the supply risk, which is related to country concentration, to governance of other countries. But also supply risk is related to our capability or not of substitute this material with something other, and our capability to have a good recycling rate of this material. So combining the supply risk and economic importance, we have the list of critical raw material, which is periodically upgraded by European Union. In this context, we have a lot of material which are considered as critical for what concerns mobility, so from magnesium to niobium, vanadium used in high-strength steels, or bauxite related to aluminum, and cobalt, and so on, and some other which are centrally critical for what concerns energy, starting from silicon to gallium to indium, and so on, and to rare earths, obviously. So the situation is quite complex, and the focus of this afternoon is related on one side, metals for clean energy, the pathways to solving a Europe raw materials challenge, which is the topic which will be presented by Heron. And then we have the issues related to magnesium, which will be presented by Mark Pohlmann. So I ask, first of all, to Heron to come here. I will give a short introduction about him. He joined the Eurometaux in 2014 after 3 years working at Kellen, a global association management consultancy. He is very interdisciplinary since he has a bachelor in English literature from University College in London and a master in European politics from Leiden University. So, please,
Thank you.
Space for you.
Thank you. You heard my distant history, and the more recent history is you saw me this morning as well. So good to see you again for the second time. This morning I had more my lobby hat on, and this afternoon I have more the academics hat, because I'm here to present a study that we completed in 2022 with the Belgium University KU Leuven, which looked at metals for clean energy in Europe and quantified the supply-demand challenge we have ahead of us. Normally, the academic from KU Leuven would be here to present the results of her own study. Unfortunately, she has left KU Leuven now, so I'm here to present the results, which is a pleasure. What I'm going to do in the next 10 minutes is change my slides. Or not. There we go. I'm going to give a presentation in 3 parts. First, we're going to define Europe's raw materials challenge. We're going to talk about how the Critical Raw Materials Act itself is linked and addressing the scale of that challenge, and then quantify where are we today in actually meeting the Critical Raw Materials Act goals, tying a lot to the discussions we've already had this morning. I just have to press this button very hard, I think. Maybe someone's helping me. Anyway, I'll continue. Should this work? Yes, perfect. Yes, so the reason we're all here is because we know now that the energy transition is a commodities transition, and as a society, we're moving away from an economy based on fossil fuels to one where the key enabling raw materials are metals. And as we've heard, the faster the world decarbonizes, the higher its metals requirements. What we looked at firstly is how much on a global and a European level. Some very high-level stats is the world on its current climate trajectories will be heading to use 45 million tons of extra metals demand by 2050. You can see a big chunk of that, of course, is aluminium from what we looked at. But if the world is to accelerate its climate commitments in line with the Paris Agreement, as we hope it will, that number will increase by 1.7 times to 75 million tons. Europe's energy transition itself is leading to a massive increase in metals demand by 2050, especially if we're successful in building the supply chains for the energy transition here in Europe. In our study, we identified 3 core enabling groups of the energy transition: the base metals, the battery materials, and the rare earths. There are a number of others which we just saw on a slide too, but I'll just focus on these 3 core groups today. You can see the others at the bottom of the slide. For the base metals, aluminium, copper, silicon, also zinc, as we know, they're used around us in our everyday applications already, in our cars, our packaging, our electronics, and more. They're also fundamental for electrifying the European and global economy. And that means that the demand for these materials, very high volume already, we think will increase by between 30 to 50% over the next 2 decades. Battery materials, it's a different story. Nickel, cobalt, lithium, manganese, and graphite. These aren't really used much in the European economy today, apart from nickel in stainless steel, and so the percentages are far higher. Doubling of our nickel consumption, 300% more cobalt, and a massive 3,500% more lithium over the next 3 decades. These battery materials are often capturing the focus in the critical materials debate. And then lastly, the rare earths, praseodymium, dysprosium, and neodymium, their supply chains are completely controlled by China today, but they're fundamental for our permanent magnets in our electric cars and our wind turbines, and so the percentage increase we expect for them in Europe is significant as well. Then on the bottom, you've got platinum group metals, germanium, gallium, magnesium, and more. The demand for these metals is one thing, but there's been 2 key concerns which has been driving policymakers' responses in Europe and globally. Concerns about the challenge of security of supply and of sustainability of supply. The first challenge of security of supply is how can we overcome the ever-growing gap between metals demand and supply in the next 15 years? We like to use the example of lithium because it's a very clear one, where the world will be needing 3 million tons of extra lithium demand by 2030. The problem is, if we add up today's global supply and all the projects announced in the world, we'll still have a 37% shortfall in 2030. And those markets are very turbulent. We can see at the moment that the lithium price is down a lot because there's a temporary oversupply situation, but long term, that shortfall is still the reality. And then the second challenge, which we've also discussed today, is sustainability of supply. How can we avoid Europe's demand gap only being filled with imports from unsustainable single suppliers? Here, Europe wants to avoid replacing its dependency on Russian fossil fuels with a dependency on Chinese metals in particular. We know that China has a very high share of processing for a number of key strategic materials, 35% for nickel, 40% for copper, 60% for aluminium, 65% for lithium and cobalt, and over 90% for rare earths. I could have added magnesium, silicon, germanium, gallium to this slide as well. China is also very effective at controlling our global resources. Where it doesn't have the mines itself, it goes globally. It controls 15 out of 17 cobalt mines in the Democratic Republic of Congo, a majority of Indonesian nickel with a very high carbon footprint, and lots more lithium in South America. And it's these two challenges which have really driven the urgency of the policy response we've seen in Europe with the Critical Raw Materials Act being driven through. From our side, and in the study with KU Leuven, what we put forward is this concept of a raw materials bridge. A bridge that takes us from where we are today, where we want to speed up our clean energy transition and improve our strategic autonomy, to an end point in 2050 where we achieve both of those things together. Our message here in Brussels has been that we need to build 5 essential and irreplaceable pillars to bridge the gap we have ahead of us. Pillar 1, we need to fulfill our domestic mining potential. Pillar 2, we need to maintain and increase our domestic refining output. Pillar 3, we need to secure sustainable imports from reliable partners. Pillar 4, we need to maximize recycling, including new streams. And Pillar 5, we need to drive technological and behavioral change. We need to get better at using less wherever we can. Now, the key messages on this is it's not a question of or between these pillars, but and. We need to deliver on all 5 of them together. Each material will have a distinctive set of balances between what's the most important ones to put the focus on. One key trend, especially for the newer commodities, is that recycling and technological change will be much more important next decade once the scrap comes through from our energy technologies and once maybe some more substantial shifts are made in our consumption patterns. That was the bridge we put forward in 2022, and what's been interesting is that the Critical Raw Materials Act itself is effectively setting targets for Europe at each stage of the bridge. Europe wants to ensure that by 2030 we are supplying at least 10% of our mined needs from domestic sources, at least 40% of our process needs, that no single supplier into the EU market should have an import share of above 65%, and that recycling, as we've heard this morning, should be comprising at least 25% of EU demand. This sets a clear direction of travel, as I said this morning, but there's also questions about what do these numbers actually mean in practice. And that's, for the rest of my presentation, the burning question for our work ahead. To what extent are we in Europe actually on track to meeting these 4 2030 benchmarks? One thing I can do is show you a map of all the projects that have the potential to come online by 2030 in Europe across those supply chain stages. You'll see there's a spread across member states and a spread across materials. There are some magnesium projects on there. There are some aluminium recycling projects there. There are a lot of other projects there too. But that isn't really telling us how close we're going to be to actually improving our self-sufficiency and resilience. For that, I like to talk about it in terms of a weather forecast. We know we have the potential, but what's actually the forecast for us to meet our 2030 goals? Here to go back to those 3 groups I mentioned at the start of the presentation. For base metals, copper, aluminium, zinc, and silicon, we would say it's more of an overcast forecast, because when we look at the capacity we have today, if we can keep that operational, then it's mostly meeting or exceeding Europe's objectives. For the battery materials, it's a rainy forecast, but there is some sun on the horizon. It's rainy because apart from nickel and some cobalt, we're not really producing these materials in the quantities we want to in Europe at any of the supply chain stages. But on the other hand, we do have projects in the pipeline that could take us a lot closer to the benchmarks if they're operational. So there is some sun on the horizon. And then, of course, there's another list of other key materials, graphite, rare earths, manganese, magnesium, germanium, gallium, others, where we still see a heavy rain ahead forecast. There are projects for each of these commodities. We'll hear about one of them soon for magnesium. There's projects on all of them, but they're not getting us to the extent we need to be meeting the EU's benchmarks for 2030. So clearly some more action is needed. And a final message is that we all know the energy crisis has brought major thunderstorms for everyone. So even though the weather forecast for our base metals looks overcast, it's, as you know, in the aluminium sector, very difficult at the moment for several parts of the supply chain. What I won't do today is go into detail on these different tables, which actually give the numbers in the study for where Europe is across the different supply chain stages. But what I'll do, I'll just skip through them quickly, and you'll see that the colors shift from green to orange to red, reflecting how close Europe is to meeting the benchmarks that it's set. The message I added in is that indeed we have 50% of our aluminium zinc capacity, now 60% of our silicon capacity offline already in 2023. So can Europe be affording to deindustrialize further as well? For battery materials, you see a lot more yellow. And then for that last group of materials, it's a lot of red or yellow. And we really don't know how much of our projects we're actually going to be bringing back online. One key challenge we have as well is you can see the very high share of China for a number of these supply chains. That makes it particularly difficult to bring projects online in Europe because China, if it has that control of the market, has a control of the price as well. Often it's producing at a much lower cost. So when that situation is there, what measures do we need to bring production up? I'll be interested to hear from our next speaker there as well. But of course, whatever the forecast, Europe's raw materials bridge must be built. So although the weather forecast might look gloomy, I think that just shows us the urgency of action to start taking action across all of these 5 pillars. We need to build the strong foundation for a lasting raw materials bridge. And one key thing missing in Europe today is the business case. If we want to build a battery materials refinery in Europe, it costs 2 to 3 times more than if we were to do so in America or Asia. And the operating costs, especially from energy, will be 20 to 50% higher. So that's a gap that we really need to bridge urgently. 3 things to close with about what's still needed in our perspective, and that's to put the lobby hat back on. Adequate EU finance to bridge the competitiveness gap for our EU-owned projects, to take learning lessons from the IRA and its clarity and its simplicity and its OPEX focus. Secondly, meaningful action to bring down the still high EU energy prices and making sure we have green electricity available at competitive prices at the quantities we need. And then lastly, a level of market incentives may be needed to encourage downstream users to buy sustainable and buy local, especially when China has control of these supply chains and prices. And that's my run through the study that we've done with Kerry Leuven. Happy to answer further questions and looking forward to hearing the next presentation. Thank you.
Thank you, Chris, for the presentation, for giving a lot of information in a short time.
Yes.
It's very clear, very interesting. Is there any question from the floor? Perhaps I can start. You presented the 5 pillars for this perspective future. Which is the most difficult or most critical pillar? For instance, the first one about mining. Do you think it's a target reasonable, considering also the social and economical issues in Europe, to restart some mining?
Yeah, I think all the pillars are equally important and have challenges attached. The mining for specific commodities is an important one. We have the lithium in our ground and the projects for lithium that could supply 39% of our needs by 2030 if we open the mines. But as you know, there's a lot of social opposition to that. The permits are hard to get, and there's other challenges too. But I would maybe put the focus on the second pillar in the midstream. We can open the mine, but we need the processing capacity there to then transform it. And that's where we see the biggest problem with the business case. We have the problems with our existing smelters, which I spoke about, but making the business case for an investor to invest into processing here in Europe at the moment is very difficult. So if I had to pick one, I would say get the business case for the refining. Even if we don't open the mines, we still need that refining capacity there to meet the downstream needs.
Okay. Any other question? Yes?
Okay, thank you, Chris. Very interesting overview. Linked to the question of this morning about, let's say, the anthropogenic reserve, let's say, created for these different critical raw materials, is there anything in this report already available, or this could be a next step, because this was highlighted as a...
Yeah, there is. I didn't go into it, but we looked at the recycling flows of all of those commodities I mentioned. We made projections of the scrap in the European market and what will be coming available to recycle over the next years. For aluminium, you can see, as you know, you're able to increase your recycling contribution, even as the demand for aluminium is increasing, which is a good story. And we also looked at things like the battery materials and how much battery materials would be coming into the European scrap flows in 2035, 2040. And there, the positive conclusion, which I didn't mention, is by 2050, recycling for most of these commodities can be Europe's major supply source, because of all of the scrap will eventually get through. It'll still be 60%, 70%, but that's fairly significant for things like battery materials that recycling could be giving that job. So would encourage people to read the full report for that granular level of detail, definitely.
Thank you. I think we have time for another couple of questions. Yeah.
Yeah, great presentation. Lots of wonderful information. Hopefully it's widely available.
It is.
The thing that there was nothing in there talking about issues concerning improved materials, so you need less, keeping things in circulation longer, so you need less. I mean, don't you think that there's any chance of that sort of having any impact in time?
Yeah, that's the fifth pillar of our bridge, is reducing the material intensities, reducing the need for the materials in the first place. It contains a lot under that pillar. Just the efforts industry is doing to reduce concentration of metals in the products themselves, the new business models that might come for mobility sector in particular, and yes, substitution as well. So certainly contained under there. One striking conclusion is, of all of these materials, 75% of all of that is in the automotive sector. So if there's one application to really look at, it's the automotive sector here, which is relevant for this discussion.
Don't you think the automotive sector is really ripe for a huge change, where we just don't all run around in cars like we have been? I don't think Europe can afford it. We can't afford the vehicle fleet to keep growing as it has. Things, you know, it's business as usual just isn't possible.
No, I mean, I said this morning, at least on the recycling side of things, that we're appreciative when DG Environment is taking things further for the automotive sector than the business as usual. I won't comment on the bigger picture of changing consumer patterns. That goes beyond my job context. Thanks.
Okay, I think we have time for the last question from the floor. Yes.
Good afternoon, Francesco Di Maio from Delft University of Technology. Considering what you take into consideration, what you have shown today in your presentation, do you think that the transition to electric vehicles is still make sense? Does it still make sense?
Yeah, I think these challenges they can be tackled and overcome, but they require an urgency of action to do so, and to do so now. We've already seen for some of the battery materials there has been a response to bring mines online around the world. I think it's certainly tackleable at a global level. My concern for Europe would maybe be that if we're not taking the lead in tackling it, that import dependency pillar we have will be by far the biggest in terms of how we as Europe are bridging the challenge, and that's not the desirable outcome. So I think we have what it takes globally and to bridge this gap, but as Europe we need to make sure it's not leaving us import dependent as a consequence.
Thank you.
Okay. Many thank you.
Thank you, Franco.
Chris, for the presentation.
Goodbye.
Nice. And during this morning and also this section, we mentioned a lot of times magnesium, and now it's time to discuss specifically about the sustainable magnesium production in Europe. The topic is presented by someone told me that I can call him as Mr. Magnesium. However, he's Mark Mark Pohlmann has a career in the field of investment banking, asset management, investment, and with experience including developing financing companies, also as a head of the investment banking division of UBS Germany and Jefferies Germany. Mark,
thank you.
Please.
Yeah, I mean, with my finance background, I don't really deserve the title of Mr. Magnesium, but still, thank you very much. I must say, I was a little bit discouraged this morning when I heard about all this fantastic technology in recycling. And I thought, are we going to go into a complete circular economy? But then Chris presented his presentation, and that really encouraged me because I mean, we're coming from the mining side of things, and that together with the statistics on magnesium are really very encouraging. So let's kick this off. I'm one of 6 founders of MFE, Magnesium for Europe. MFE is a project company, which means we're not producing yet, but we're very advanced in the planning for a magnesium production facility. And that is to be located in Bosnia-Herzegovina, and it's supposed to go into operation in 2026 with an initial capacity of 15,000 tons, which can be expanded to 30 or even 50,000 tons. And if you quickly look at the cover page, this is the landscape. That's Canton 10 of Bosnia-Herzegovina, which is the very western part bordering on Croatia. It's only, from our side, it's only 50 kilometers to the border of Croatia, which is also the EU border. And it's only 150 kilometers to the port of Ploče, which is the major gateway for goods shipped and from and to the Balkan. So it's logistically, it's a very good location. Oops. Okay, now I'm the one having trouble here. Is that the right one? Yeah. Ah, here we go. Excellent. Sorry, this one. Okay. So let's take a quick look again at Europe and its need for magnesium metal. Europe needs about 200,000 tons of primary magnesium every year. But there are 3 fundamental problems with this. I mean, first, and we mentioned that before, all the primary magnesium that's currently being consumed in Europe is produced by Chinese producers. The second issue is that the Chinese themselves are ramping up their use of magnesium. And there's talk about going from 4 kilos per vehicle to 40 kilos. I don't know if it's going to be that extreme. But if they indeed increase their own need or consumption of magnesium by more than they can expand their production capacity, then that means they will cut exports, and here in Europe we're going to receive less. And then the third problem is that the Chinese are still using the so-called pigeon process, which is a process that is fairly energy intensive, produces waste, and also large amounts of CO2. So the question is, how do we solve this riddle? How can we improve the situation for Europe? And from our perspective, there are 2 ways. I mean, one is to bring back magnesium production to Europe, but in a sort of cleaner, greener, and more competitive way. And the second one is to find substitute materials. I'm not the right person to opine on this, but for all I know, it's fairly R&D intensive, has long lead times with an uncertain outcome. And then I realized this morning I should probably add a third number here, which is sort of use less of the material and make use of the recycling capabilities. So that's our mission. MFE wants to reestablish primary magnesium production in Europe, want to offer clean, green, cost-competitive, and regionally produced magnesium. and thereby become the supplier of choice for European industry. Now that mission was originally motivated by the ownership of a large and high-quality raw material source, because a number of friends of mine and we invested into a dolomite mining company in Bosnia-Herzegovina several years ago. And then when we realized that this was the main feedstock for magnesium production, and that together with the magnesium crisis made us look very carefully at the material. And we found out that it was extremely well suited, the raw material that is. And then on top of that, we were motivated by two other factors. One was a progress in magnesium production technology, and the other one was the regional availability of all the relevant inputs, including green energy, good infrastructure, skilled labor, and these sort of things. I mean, clearly there were questions initially, why bring back magnesium production to Europe? There was a problem in Europe 20 years ago when magnesium production, primary magnesium production was stopped here in Europe. And the main problem was really that it was a single product process. It was labor and energy intensive. It was too expensive for Europe. And it was, on top of that, it was dirty, and all of that, together with the very poor profitability, made Europe stop producing magnesium. And then we basically let the whole industry migrate to China. And here's here's really the problem with the pigeon process graphically presented. I mean, you have dolomite as the feedstock, calcination, blending with ferrosilicon. In the reduction, you get slag, which is solid waste that you have to dispose of, and you get only one product, which is the magnesium. And then, as I mentioned earlier, on top of that, you have 20 to 25 tons of CO2 per ton of magnesium. The economics are not much better either. I mean, in China, they managed to produce a ton of magnesium at $2,500 to $3,000. In Europe, the cost is typically 20 to 30% higher, which means $3,500 to $4,000 per ton. And if you look at the current magnesium price, it would be very difficult for a European producer to operate profitably. Certainly there wouldn't be any wiggle room if there was price volatility or price decline. And therefore, it's not surprising that we haven't seen more magnesium projects here in Europe in the recent past. So the big question is, what's different with MFE, and why are we taking on this challenge? Because, yes, my co-founders and we had successful careers, and there is an element of patriotism in our activity, but we're clearly not a charity. So what really makes the difference for us? And to summarize it, it's two catalysts. One is technological progress, and the other one is the suitable location. And I'll elaborate on these two in a minute. But they result in what I call MG Production 2.0, which is competitive because there are byproducts originating in the process. And these reduce the allocable magnesium unit cost. It's clean, because the new technology, the latest technology that I'll speak about in a minute, is highly efficient with zero waste. It's green because you can power the process almost entirely with green electricity. and therefore greatly reduce the CO2 emission or CO2 footprint. And it's reliable because it's local, and that's clearly what we want in times of geopolitical tension. And here is the first catalyst, the technology. It comes in the form of the althermic process. Actually, the full name is aluminothermic process. And it's a further development of the pigeon process, which is the reason why the flow diagram looks quite similar. But there are three important differences. I mean, first, the althermic process is run at a slightly lower temperature of 1150 degrees instead of 1250 for the pigeon process. Secondly, it involves one more process step, which is the calcium-magnesium separation. And then the third difference is that you reduce with aluminum scrap, rather than with ferrosilicon. And you might say, well, those are only three small differences, but they make for a fundamental difference because now, instead of one product, the magnesium, you get four outputs, and these are all sellable products. So the tailings at the three process steps prior to the refining are basically generating products with market value. Secondly, you have a zero waste process. I mean, if you remember, for the pigeon process, there was this trash can next to the slag resulting from the reduction. Here you only see a sellable product. And the third difference is that you can power the process almost entirely with green electricity and therefore reduce the CO2 footprint. And we had a study done by DLR in Stuttgart, an LCA study, and that said that we will produce magnesium with a CO2 footprint of less than 1 ton per ton of magnesium and byproducts. So I'll share with you in a second what the economics look like, because that's clearly the super interesting part. But let me first make a few statements on the althermic process. The althermic process is for real. I mean, we are currently running a 40-ton industrial scale pilot test on a 5,000-ton althermic plant in China. We have asked DMT TÜV Nord to act as independent auditor for the test as well as the technology as a whole. And they've been with us to China and they looked at it, and they've come up with this first report, but there's going to be a much more comprehensive report soon. Secondly, the althermic process is based on technology that is actually quite old. It's a technology known as the Magnesium process, which was developed in the last century by Alcoa. But it was then sort of not used because the Chinese, they put all their money on the pigeon plants, the pigeon process. But with increasing pressures also in China to be more environmentally friendly, they have revisited this process and refined it over the last decade or so to a fully fledged technology with a TRL level of 8 to 9. And in China, they already built 4 or 5 plants which are operational, and that's the reason why we're doing our test there, because here in Europe we don't have an althermic plant. So our prediction is that the althermic process will gradually reduce the pigeon process for all the advantages that I mentioned earlier. But that will take several years, if not decades. And therefore, we believe now is the time to reintroduce magnesium production to Europe using this latest technology with all its advantages. But there's a second catalyst, as I mentioned. and that's the location with its specific advantages. So the location that we have by default, because our raw material source is there, has a number of other advantages which play together to make for this very powerful combination. I mean, we have raw material access to over 100 million tons of dolomite. We have only green electricity in Canton 10. It's either hydropower or wind power. They are ramping up considerably their wind power capacity because geographically they're just very blessed with the because it's a mountainous area that's great for hydro. They have all the winds coming from the east, and then they have as many sun hours as in the south of France. So they also have photovoltaic plants. And therefore, the energy costs are also quite attractive at sort of 8 to 10 cents per kilowatt hour currently. Country has a good infrastructure, and it's also very close to Europe, as I mentioned earlier. And it's an EU, it has EU applicant status. And if I trust the press of this morning, then currently the EU leaders are meeting here in Brussels to discuss whether to start accession negotiations with Bosnia-Herzegovina as soon as possible. I mean, clearly these Balkan states have been waiting in the wings for quite some time now. So here's the beef, here's the economics. Let's tackle this in steps. I mean, if you first look at the left-hand side, please. I mean, these two columns are basically the costs associated with the production of 1 ton of magnesium and 12 tons of byproducts. And you might say, where are the numbers? I'm sorry, I had to delete them for confidentiality reasons, but the proportionality will give you an idea of what we're looking at here. So the colors represent the different inputs, and the biggest ones are the L scrap, which is the gray part at the bottom of the columns, and the electricity, which is the green part further up. And as you can see, the only difference between the two columns on the left is the electricity, because the left column assumes electricity from the grid, and the right one assumes self-generated electricity, because we're also in the process of discussing an own wind and solar park with local regulators and local policymakers. Now let's move over to the right-hand side. And on the right-hand side, the colors represent the 4 output products. Again, at the bottom, I just need 5 more minutes, sorry about this. So on the right-hand side, I mean, the gray part is magnesium. Then you have the 3 other byproducts. And the observations that I want to mention here is that magnesium is clearly the most valuable parts. The 3 byproducts are slightly, in combination, are slightly more valuable. And if you compare them to the cost column, I mean, with the byproducts, we're more or less covering the cost, which means that we have enormous pricing flexibility on the magnesium, because the magnesium is essentially the profit. The second column on the right is just the same with a higher magnesium price. That was the situation if we were to deliver the magnesium, if we were to sell it to the US market. And then the far right-hand column, that's actually the most interesting one. That's where we have allocated the cost to the 4 products according to their sales value in Europe. And as you can see, I mean, the gray part, which is the cost of producing the magnesium, is roughly 50–60% of the production cost, as we have displayed it here in the left-hand column. Almost done. Oh, sorry, can I go back? Oh, yeah. Now, given that the byproducts make such a significant contribution to the profitability, I mean, we've done a ton of work on these, and the markets, the buyers, but the three important findings are basically that all the underlying markets for the byproducts are growing. There's a lot of depth and demand. The product prices vary according to quality, and that's actually good news for us, because the input, the raw material, the dolomite, is of such high quality that the outputs are also high quality, and that's why they fetch the prices that we have shown earlier. This is just a list of the companies that we've been working with. It's actually just a selection. But as you can see, I mean, we've taken a deep dive into the different facets of the project with very respectable companies, and we're pretty advanced. This is just to put some faces to our project. It's a collection of individuals with complementing backgrounds. Albrecht, for example, is an industrial minerals specialist, ex-CEO of Omnia, the Swiss industrial minerals company. Ilhan is our CTO, and I say he's the only living individual who's ever built a magnesium plant in Europe, and that is for Esan in Turkey. And I have a finance background. Jure is our local networker. Jan is now a local managing director of the mining company. And this is the status of the, and last slide of my presentation. It's basically, we're about to complete the pilot test. We have 7 out of 8 local permits. Then, once we have these 2 ticked off, we will care about the funding, and that's a big challenge, I can see. So we will be busy with that probably Q3 of this year, and then hopefully at the end of Q3 or Q4 we will go into general contracting, equipment orders and construction for a start then in 2026. So thank you very much. Thanks for listening.
Thank you for your presentation. I think it was really relevant. It was really relevant for us to have a perspective about the scenario for Aluminium Europe, and this is really a challenging project with some really interesting challenges and results perhaps in a short time.